This video is sponsored by Taskade, a real-time organization and collaboration platform. Make sure to check the description for a discount on your subscription. Hey everyone, my name is Vishwas and welcome to the React Fundamentals Crash Course for complete beginners. If you're aiming to become a front-end web developer, you're at the right place as React is one of the most popular libraries you can learn. Before we begin, let me go over a few points to give you an idea of what this video is and what it is not. First, I would like to mention this course is for complete beginners. I'm going to assume you have no prior knowledge of React and teach the course. If you're someone who is already familiar with React, this is your cue to probably hop into another video where your time can be better utilized. Second, this video is a continuation of the HTML, CSS, and JavaScript crash courses. Make sure you're familiar with all the three before proceeding. Please make sure you also have an idea of some of the ES 2015 or modern JavaScript features as well. You don't have to be an expert by any means, but some knowledge is definitely helpful. Third, we're going to learn React from a beginner's perspective. React does have quite a few advanced topics that are difficult to understand when starting new. So we will focus on topics that a beginner must know when getting started, and you can then use that knowledge to dive deeper into React. You can find all sorts of React content in this channel, so I will guide you on the next steps at the end of this course. Fourth, in this video, we will be using React version 18, which was released on 29th of March 2022 and is the latest stable release. Having said that, we will only cover new features from version 18 that are applicable from a beginner's perspective. This is a fundamentals crash course, and quite a few concepts in the new release are pretty advanced, which will only confuse you. As a beginner, be rest assured you're learning the latest stuff. Finally, unlike other videos in my channel, this video is a crash course and is longer in length. That doesn't mean you have to sit through the entire video at once. Take it easy, pause when necessary, and most importantly, make sure you code along with me, as that is the best way to learn. By the end of this video, you will have a solid understanding of the fundamentals in React. Alright, with these points in mind, let's get started. What is React? React is an open source JavaScript library for building user interfaces. There are two key points in this definition. The first one is that React is a JavaScript library. It is not a framework, it is a library. It is focused on doing one thing and doing that one thing really well. And that is the second part, building user interfaces. So React does not focus on the other aspects of your application like routing or HTTP requests. It is responsible only for building rich user interfaces. However, there is no need to worry as React has a rich ecosystem and plays really well with other libraries and is more than capable of building enterprise-scale web applications. Alright, now that we know what React is and for what purpose it is used, let's see why you might want to learn React. Well, the first reason is a practical one. It is one of the most popular UI libraries and is well known in the job market. Learn React and you could land that front-end developer job you've always wanted. Second reason is that React has a great community behind it. You will be able to find tons of articles and Stack Overflow solutions to most of the problems that you will encounter when learning React. Next, let me touch slightly on the technical aspects of React and why it is a good choice. React has a component-based architecture. This lets you break down your application into small encapsulated parts, which can then be composed to make more complex user interfaces. Components also make it possible to write reusable code. For enterprise applications, the ability to reuse code is a huge plus point. Another key point is that React is declarative. Now, what does that mean? Well, basically, you just have to tell React what you want through code, and React with its React DOM library will build the actual UI. React will abstract away the difficult parts and make it painless for you to create complex UIs. The bottom line is that React will be a great addition to your skill set. Alright, with this introduction in mind, let's create our very first React application. Let's begin by setting up our development environment. For React, we need three things: a browser, Node.js, and a code editor. For browser, I am going to be using Chrome. You can choose to use any browser you already have installed. For Node.js, head over to nodejs.org. You will need to download and install the latest stable release. Click on LTS, which downloads the installer. Double-click the installer, stick to the defaults, and install Node.js. To write code, I am going to be using VS Code. Head over to code.visualstudio.com, download and install the same. Once you have VS Code installed, from the side panel, open the Extensions panel and make sure to install the Prettier extension, which will help with formatting. Finally, open the editor inside a folder of your choice. I have created a folder called React Crash Course, and I've opened VS Code inside the folder. This pretty much is all the setup we need. We are now ready to create our React application. To create a new React app, we will be making use of Create React App. Create React App is a command line interface tool that allows you to quickly create and run React applications with no configuration. So open the integrated terminal, View, Terminal, and run the command npx create-react-app followed by the name of the project. Let's call it React-demo. The command takes a few seconds, and once it completes, you should have a new folder called React Demo. This folder contains our React application. To run this application, first navigate inside the project folder. cd react-demo. Now run the command npm start. The command will open the browser on localhost port 3000 with your React demo application up and running. And you can see the instruction: edit source/app.js and save to reload. Let's go back to VS Code, expand the source folder, and edit app.js. I will change the text to Hello World and save the file. When the changes are saved, the browser automatically refreshes and you should see Hello World displayed in the browser. So there you go, your first React application up and running. Now that we understand how to generate a simple React app, let's understand the application's folder structure. At the root level, we have 3 folders and 4 files to begin with. Let's start with package.json. This file contains the dependencies and the scripts required for the project. You can see that we are using React and React DOM version 18, and they are listed as dependencies. Both the libraries are necessary to create React applications. We also have a few scripts to run the application, build the application, or even run tests. We then have the configuration for ESLint, which is a tool to highlight possible errors in the code. Finally, we have the compatible browser list. Next, based on whether you have npm or yarn as a package manager, you're going to see yarn log or package log files. This file ensures consistent installation of your dependencies, and you don't really have to worry about it. We also have a git ignore file to ignore files and folders from version control, and a standard README file. Next, let's talk about the folders. The first one is node_modules. This is the folder in which all the dependencies are installed. It is generated when you run the create react app command or when you run npm install. The next folder is the public folder. This folder contains 6 files. Out of the 6, manifest.json along with the favicon and the 2 logos are concerned with progressive web apps, which is out of scope for our discussion. We have the robots.txt file, which is needed for search engines and is nothing React specific. So as a beginner, you only have to concentrate on the index.html file. The index.html file is the only HTML file you're going to have in your application. We are building single-page applications, and this is it. The UI might dynamically change in the browser, but it is this HTML file that gets served up. Typically, you're not going to add any code in this file. Maybe some changes in the head section, but definitely not in the body tag. You want React to control the UI. And for that purpose, we have one div tag with ID is equal to root. At runtime, the React application takes over this div tag and is ultimately responsible for the UI. Please make a note of this div tag as we will come back to it shortly. The next folder is the source folder, which is the folder we will be working with the most during development. The starting point of our React application is index.js. There's quite a bit of code here, so let's focus on the most important bit at the moment. In index.js, we specify the root component, which is app component, and the DOM element, which will be controlled by React. The DOM element in our example is an element with ID is equal to root. And if you can recollect, this is the element in our index.html file. We call this div element as a root DOM node because everything inside it will be managed by React. For the Hello World application, the app component is rendered inside the root DOM node. That brings us to the app component, which is present in app.js. This is also the file we edited a minute ago and is responsible for the HTML displayed in the browser. In other words, the app component represents the view which we see in the browser. With app.js, create React app also generates a CSS file for styling and a test.js file for unit tests. The CSS file contains classes which are applied in the app component, and the test file contains a simple test case. We also have an index.css file which applies styles to the body tag and is referenced in index.js. We have the logo SVG, which is referenced in the app component at the top here. And finally, report web vitals for performance and analytics tracking, and set up tests, which is again related to testing. These two files can be ignored as a beginner. So that is the folder structure of a React application created using create React app. When you run the command npm start, index.html file is served in the browser. Index.html contains the root DOM node. Next, the control enters index.js. React DOM library renders the app component onto the root DOM node. The app component contains the HTML, which is ultimately displayed in the browser. Now, although this works perfectly fine, there is a small update needed in index.js. At the moment, Create React App installs version 18 as a dependency, but the root API still uses version 17 of React. Let's fix it before proceeding. At the top, comment out the import statement for React DOM and instead add import create root from React DOM/client. Next, comment out the React DOM render method and instead add const container is equal to document.getElementById root. Const root is equal to the create root function which we have imported, passing in container, and finally root.render the app component. Doing this will enable you to use React 18 features. If you're watching this video a few weeks or months after the video has been published, you might not have to do this as Create React App might be updated by then. But for now, make this small change to render the app component. Now, I have mentioned the word component several times already. But what exactly is a component? Let's understand that next. In React, a component represents a part of the user interface. For example, a traditional website can be broken down into header, side nav, main content, and footer. Each section is represented by a component in React. All the components, when composed in the right way, make up the entire website. We also have a component that contains all the 4 components. It is called as root component and is usually named as app component. Components are also reusable. The same component can be used with different properties to display different information. For example, the side nav component can be the left side nav as well as the right side nav. The UI can remain the same, but the content can change. Now, how does a component translate to code in our application? A component code is usually placed in a JavaScript file. For example, app component is placed in app.js. Alright, so a component is basically the code inside a .js file. But what does that code look like? That depends on the type of the component. We have 2 types, function components and class components. In the year 2022, function components are pretty much what you need to learn, and our focus is going to be just that. Class components are not necessary from a beginner's point of view, but I will let you know where to learn about them at the end of this video. So what does a function component code look like? Function components are literally JavaScript functions. They may accept some input properties and return HTML, which describes the UI. Alright, now that we have some understanding of React components, let's examine the app component in our application. If I go back to VS Code The first thing to notice is the file extension .js. So it is a JavaScript file. If we take a look at the code, you can clearly see that this is a JavaScript function called app which returns some HTML. The HTML contains a wrapping div tag, the header tag, an image, a paragraph, and a link. The component is exported from the file as the default export. This allows us to import the same in index.js. Create React App generates a simple React application, and hence we have just the one component, which is app component. In a real-world application, you can have tens, hundreds, or even thousands of components. Facebook, which uses React, supposedly has more than 30,000 components. More complex the application, more the number of components. To get a better hang of components, let's now create a function component ourselves. To keep things simple, in the app component, I am going to remove all the HTML except the outer div tag. Remove the logo import as well at the top. Now let's create our first component, which will simply output the message, "Hello Vishwas." Now a component is nothing but a JavaScript file. Let's start with that. First, within the source folder, I'm going to create a new folder called components. And within the folder, I'm going to create a new file called greet.js. Now, within the file, define a new function. Function greet. We return an h1 tag that says, "Hello Vishwas." And that is pretty much it. You have created your first function component. But as it stands now, the HTML "Hello Vishwas" is not going to be rendered in the browser. The greet component is in no way connected with the rest of our application. So what we have to do is export the greet function from greet.js, import it in app.js, and then include it in the app component. So export default greet, and in app.js, import greet from /components/greet. We are allowed to omit the .js file extension. Now to include the greet component in app component, we simply specify the component as a custom HTML tag. So within the outer div tag, include the greet component as an HTML tag. If there is no content between the opening and closing tags, you can simply change it into a self-closing tag. Now, if we save all the files and take a look at the browser, you should be able to see "Hello Vishwas." Your first function component is up and running. It's also possible to use an arrow function to create a function component. Let's rewrite the code. Const greet is equal to an arrow function which returns "Hello Vishwas." If you're new to arrow functions, please pause the video and try to get a basic understanding of how they work, as we will be using them a lot throughout the series. Take a look at the browser, and we still see "Hello Vishwas." Alright, before we proceed, I would like to highlight a point about exporting and importing components. Please note here that we are exporting greet component as a default export from greet.js. This is what allows us to import the component with any name. I can change greet to my component, change the tag to my component, head back to the browser, and you can see that it still works as expected. But in certain articles or videos, you might also find named exports. Let me comment the default export and prepend the constant with the export keyword. So export const greet. This is what is termed as a named export. In this situation, you have to import the component with the exact same name. If I save the file, you can straight away see we have an error. Export default imported as my component was not found in components/greet. So you have to change the import statement to import the greet function. For named exports, we use curly braces and then the export. So import greet from ./components/greet and use the same tag. If we take a look at the browser, our app is working once again. Now I am going to be using named exports for the most part, but make sure you understand the difference between default and named exports. For our next topic, we're going to quickly take a look at JSX. JSX is probably the word you're going to see and hear a lot in the world of React, so it's really important that you at least know what JSX is from a beginner's point of view. If we take a look at our greet component, we see HTML being returned. However, this is not HTML. It is called JSX and is a syntax extension to JavaScript. In React, JSX is what describes how the UI should look like. In this case, it should be an H1 element. JSX comes with the full power of JavaScript. For example, if we have to evaluate an expression within a pair of curly braces, let's specify 2 plus 2. Save, and we see 4 in the browser. We can also run conditional code, map over a list, etc. You will slowly get used to what JSX is capable of as we progress through this course. However, at this point in time, let me point out some of the differences you're going to see in JSX compared to regular HTML. The first one, which is already present in app.js, is class being replaced by class name. In app.js, you can see class name is equal to app, and app is a class defined in app.css. Similarly, we also have the for attribute being replaced by HTML4 since it is a keyword in JavaScript. You're also going to see camel case property naming convention instead of HTML attribute names. For example, onClick and tab index will become onClick and tab index with an uppercase C and I. We will see these differences as we progress through the course, so don't worry about having to memorize them. The last point you have to know as a beginner, and something you can dig into after the course, is about React elements. We write JSX, which appears to be similar to HTML, since it is the easiest way to write what the component should render in the UI. Under the hood, JSX produces what are called React elements, which are in turn converted to objects that are used to construct the DOM. The topic might be overwhelming as a beginner, so for now, just keep in mind a React component returns JSX, and JSX is simply a syntax extension to JavaScript. We will be writing a lot of JSX throughout this course, so you will get used to it even if it hasn't made much sense so far. Alright, our next topic of discussion is an important one. It is about props. Earlier in the video, I mentioned that components are reusable. So you can create a component that returns any JSX you want to and include it in any part of your application. For example, let's say we need to reuse the greet component. All you have to do is include the greet tag as many times as you want. if I duplicate it twice, save the file and take a look at the browser, you can see Hello Vishwas displayed 3 times. Now all of this is great given what we return from the component. This isn't really helpful, is it? What would be great is if we could pass in the name of the person we want to greet. That way, reusing the same component, we could greet 3 different people instead of greeting Vishwas 3 times. That is where props come into picture. Props, short for properties, is the optional input that any component can accept. It allows the component content to be dynamic. Let's understand how props work. Our intention here is to pass a name from the app component to the greet component and render that name in the browser. To specify props for a component, we specify them as attributes. To specify a name prop, we simply add a name attribute. It could be any word like username, for example, but I've decided to go with just name. To the attribute, we assign the value. Let's go with the string Bruce. Similarly, let's add the attribute to the other 2 components as well. Name is equal to Clark and name is equal to Diana. Okay, so we are now sending some information or some property to the greet component. But how do we retrieve the value in the greet component? That is a quick 2-step process. The first step, add a parameter to the function component. We are going to call it props. You can actually name this anything you want to, but the convention is to name it props. And I highly recommend you don't deviate from this. The second step is to use this parameter in the function body. Now props is an object on which you access the different properties you've passed in. So if you want to display the name that has been passed to the component, we need to use props.name. So hello props.name. If we take a look at the browser, the output is not quite what we want it to be. And that is because props.name is being treated as text. We need to instead ask React to evaluate the JSX expression. And we do that by wrapping the expression with curly braces. If we now take a look at the browser, you should be able to see hello Bruce, hello Clark, and Diana. The reusability of components makes much more sense now that we understand props. We can have a template and pass in the data we want the component to use. Let's add another prop to make sure we get a good understanding of how it works. I'm going to add a second attribute, hero name, and assign the appropriate values. Batman, Superman, Wonder Woman. And in greet component, hello props.name followed by, also known as, props.heroName. Now, if we take a look at the browser, you can see the output is what we expect it to be. Sometimes it is also possible that you might not have an idea as to what content is being passed in. But we still want the component to render that unknown content. We can do that by specifying the content between the opening and closing tag of the component and retrieving it using the reserved children property in the props object. Let's understand better with an example. On the greet component, instead of the self-closing tag, I will split it into opening and closing tags. And I'll do this only for the last component. In between the tags, I will specify a simple paragraph tag. This is children props. Now in greet component, we can render that paragraph using props.children. Below the h1 tag, I'm going to add props.children. If I save the file and take a look at the browser, you can see we have an error. This is because the JSX returned by a component should contain only one wrapper element. So we wrap h1 tag and props.children with a div tag. So within the outermost HTML element, you can nest as many HTML elements you want to. But the component should return only one element. If we now take a look at the browser, you can see that only for Wonder Woman, we have the additional content being rendered. This is children props. This paragraph corresponds to the inner HTML of the greet component. So if I were to add a button to the second greet component, with text action, and take a look at the browser, the button should be rendered for Superman. For the properties you know for sure are going to be passed, you can pass them as attributes, name and hero name. If you have no clue what is going to be passed as props, or if you have to pass in dynamic HTML content, pass it in between the component tags, and in the component definition, render the content using props.children. If at all something is specified, it is rendered in the browser, and if nothing is passed, props.children simply renders nothing. The children props is very useful when you have to compose new components from existing components. So that is pretty much the basic idea behind props. When specifying the component, you can include additional attributes. React is going to bundle all such attributes into an object which we by convention call as props. In the component definition, we can access any attribute we want to and render dynamic content. Now there is one strict rule though when it comes to props, and that is props are immutable. Or in simpler words, their value cannot be changed. In our example, if I try to assign a value to props.name is equal to Vishwas, save and take a look at the browser, you can see the application breaks. Take a look at the console, and the error message is cannot assign to read-only property name of object. React components have to act like pure functions with respect to their props parameter. You're not allowed to change it under any circumstance. Nevertheless, props is a great feature in React, and any practical React application will definitely make use of props. But if props are immutable, how do we maintain component data that might change over time? Well, to answer that question, let's head to the next topic, which is state. Now we have seen that every React component returns JSX, which describes the user interface. And a minute ago, we have seen that it is possible to influence what is rendered on the screen using props. As it turns out, there is a second way to influence what is rendered on the screen, and that is the state of the component. Let's quickly review what we've learned about props and make a comparison by learning about state. After that, let's dive into an example to get a better understanding of how state works in React components. Let's take a look at the comparison. The first one is that props get passed to the component whereas state is managed within the component. Analogy for this would be function parameters against variables declared within the function body. Because a parent usually passes down the props to the child component, props are immutable. The parent owns the props and cannot be changed by the children components. State, on the other hand, is managed within the component, and hence the component has full control to change the state. Now props are accessed using the props parameter on the function component. However, state is managed a little different. The simplest way to manage state is using a function that the React library provides, which is the useState function, also referred to as useStateHook. Let's look at an example of how state works in a component. Within the components folder, I'm going to create a new file called message.js. Within the file, I'm going to create a function component. Let me copy-paste the code from welcome.js and make the necessary modifications. I'm going to change the function name to message. The JSX, we return the text welcome visitor. Let me include the component in app.js comment out rest of the components and include the message component. If we take a look at the browser, you should see the text welcome visitor. Now here is our new requirement. We need to have a subscribe button right below the text. When we click on the button, the text being displayed should change from welcome visitor to thank you for subscribing. Now if the text message were to be sent from app.js as a prop, it would not work as props are immutable. Once the message is set to welcome visitor, it can never be changed from the message component. So the solution is to use component state. Let's see what are the steps involved. Step 1 is to import the useState function from React. So at the top, import useState from React. Step 2, invoke the function within the component. So useState with parentheses. Now this function returns two values which we can store in two constants of an array. Const array message, set message. The syntax is called array destructuring in case you want to look it up for better understanding. Here, message is a simple variable. We can call it anything, but message makes sense in this example. Set message is a function that can be used to update the message variable. Now useState also accepts an initial value as its argument. This is going to be welcome visitor to begin with. Step 3, instead of welcome visitor, we bind the state value in the JSX. Message. If we take a look at the browser, we see no change in the UI. However, since we are using state to render the message, we now have the ability to change the message. So let's create a button and on click of that button, change the message. For step 4, add an HTML button element. Before we do that, create an enclosing div tag, and then below the h1 tag, add a button with text subscribe. Let's quickly take a look at the browser and see if it works. The button is now placed right below the message. The fifth and final step is to listen to the click event on this button and change the message. We will take a detailed look at event handling in a few minutes, but this will be a glimpse into how a click event on an element is handled. On the button, we add the onClick attribute. Very important that it is camel-cased. To this event, we assign a handler. And this again is going to be within curly braces. Here, we're going to have an arrow function. In the function body, we call the setMessage function returned from useState. To this setMessage function, we can pass in a value and React will update the message variable with that value. Let's pass in "Thank you for subscribing." If we save the file and take a look at the browser, you should see the text "Welcome visitor," and when I click on the subscribe button, the text changes to "Thank you for subscribing." This example demonstrates what exactly state is in React. A state is nothing but a variable that is maintained inside a component. Unlike props, state can be changed within the component. Whenever the state changes, React will automatically update the UI to reflect the updated state value. I hope you now have a slightly better understanding of props, state, and how they're used in React. Now, before we proceed, I want to take a minute to explain the word hooks. It is something that you will hear a lot in React, so I want to make sure you're familiar with what it is. A hook is a special function that lets you hook into React features. For example, useState is a hook that lets you add React state to function components. Similarly, there are other hooks that let you hook into other features. You have useReducer for more complex state management, useEffect, useContext, useRef, useMemo, useCallback, and the more recent additions to React 18, namely useTransition and useDeferredValue. As a beginner, not every hook is important. In this fundamentals crash course, apart from useState, we will later on look at useEffect and useTransition. As for the remaining hooks, they are slightly more advanced, so I will point you to the right resource at the end of this video. Alright, for our next topic, let's discuss event handling in React. Any application you build typically tends to have user interaction. When the user interacts with your app, events are fired. For example, mouse clicks, mouse over, key press, change event, etc. Let's see how to handle events in React. We will focus on just the click event, but the concept holds good for other events as well. In fact, we've already had a look at the click event a few minutes ago, but let's look at it in a bit more detail. Let's begin by creating a new component. So in the components folder, new file called clickhandler.js. Here, define a new component. Export const clickhandler, and this is going to be equal to an arrow function. In the JSX, I'm going to add a div tag and a button within the div tag. Click. When the user clicks on this button, a click event is fired. Our goal is to capture that click event and execute some basic code. The first point you have to make note of is React events are named using camel case rather than lowercase. In plain HTML and vanilla JavaScript, you would specify onClick. That is lowercase. But in React, it has to be camel-cased. The second point is, with JSX, you pass a function as the event handler rather than a string. So instead of a string, click handler with parentheses, we're going to have click handler within curly braces. Now let's define this click handler function. Remember, in JavaScript, it is very much possible to define a function within a function. So inside the function component, we can define our click handler. Const click handler is equal to an arrow function, and within the function body, we simply log to the console, button clicked. Let's save this, include it in app component, import the component at the top, and head back to the browser to test this out. In the browser, you can see the click button. If I open the Developer Tools console and click on the button, you should see the message button clicked in the console. Our click event handling works as expected. When assigning an event handler, make sure you don't add parentheses. If you do, the function gets called when the component renders, and that is not what we want. What you should also know is that the event handler automatically receives the event as its argument. So we can specify event as a parameter to click handler and log it to the console. In the browser, click, and we see all the details about the event. It is also possible to pass additional arguments if necessary. For example, I can add another button, so copy paste, that says click 5, but this time the onClick handler will be an arrow function. This function receives the event as an argument. We then call click handler, so parentheses, passing in the same event, but also a second argument. Let's pass in a value of 5. In the click handler definition, we can add a new parameter that says count, and we set a default value of 1. Log count to the console. If we now head to the browser, click on the first button, we see a value of 1 and the mouse click event. Click 5, we see the value 5 and the same mouse click event. This is pretty much how you handle events in a function component. Let's now move on to the next topic, which is parent and child component communication. Earlier, we have seen how a parent component can pass down props to its children components. Any data in the parent component, when passed as props, is available in the children components. Now, what if a child component wanted to communicate with the parent component? Strangely, we still use props, but this time we pass in a reference to a function as props to the child component. Let me help you understand better with an example. I'm going to create a new file called parentComponent.js. Within the file, I'm going to define a new function component. Export const parent component is equal to an arrow function. Within the component, I'm going to define a function greetParent, which simply alerts hello parent. So const greetParent is equal to a function where we alert hello parent. I'm going to leave the JSX empty for now. Next, I will create another file called childComponent.js. Export const child component, and for the JSX, I will add a button that says greet parent. Now, back in the parent component, I will include the child component in the JSX. So return child component. Now for me, I have a VS Code plugin which automatically imports the child component. If that doesn't work for you, make sure you import child component from /child component. Back in app component, I will include the parent component in the JSX. So import parent component from /components/parent component and add it in the JSX. Now, if I save all the files and take a look at the browser, if I zoom in a bit, you should be able to see the button Greet Parent. If I click on the button though, nothing happens right now. But what I want is when we click on the button in the child component, I want to execute the function defined in the parent component. Basically, the child component calls a parent component's function. As I mentioned already, this is achieved using props. The only difference this time is we pass the function itself as a prop to the child component. So on the child component, let's add a prop called greetHandler. And this is going to be equal to the greetParent function. So we are passing a reference to the greetParent function. Make note of the absence of the parentheses. We can now grab hold of this function in our child component. Specify props parameter, and on click of the button, we call props.greetHandler. Let's save the file and see if this works. I'm going to go back to the browser, click on the button, and you can see the alert, hello parent. So we have successfully called a function in the parent component from a button in the child component by passing the function as props to the child component. This is something you're going to do quite often in your applications, so please make a note of it. Now, let's see how to pass a parameter when calling the parent component function from the child component. And this is where an arrow function in the return statement is really useful. Arrow function syntax is the simplest way to pass parameters from the child component to the parent component. Let me convert the onClick handler into an arrow function. Props.greetHandler with parentheses. Now we can pass in any number of parameters to the greet handler. To keep this simple, let's pass one argument, which is the string child. Let's incorporate this argument in the greetParent function. So greetParent, and we specify child name as a parameter, and in the alert statement, template literal syntax from ES6, and we interpolate child name parameter. If we save the files, head to the browser, click on the greetParent button, you should see the alert, hello parent child. Child here is the argument from the child component. We have successfully passed a value from the child component to the parent component. So this is pretty much how you pass functions as props in React components and handle the parent and child communication. Let's now move on to the next important topic, which is conditional rendering. When you're building React applications, you may often need to show or hide some HTML based on a certain condition. Luckily, conditional rendering in React works the same way conditions work in JavaScript. Let's look at two common ways to conditionally render in React. In the components folder, I'm going to create a new file called usergreeting.js. Within the file, I'm going to create a simple component. Export const userGreeting, and within the component, I'm going to define a new constant. Const is logged in is equal to false. For the JSX, I'm going to add a message that says welcome. Now what I want is for the message to be conditionally rendered based on the value of is logged in. If I am logged in, the message welcome Vishwas should be displayed, and if I am not logged in, the message welcome guest should be displayed. The first way to achieve that is using the ternary operator. So after welcome, we add a pair of curly braces to evaluate the JavaScript expression. The expression is to check if is logged in is true or false. If it is true, append Vishwas. Else, append guest. Let's save this file, include it in app component. So user greeting, import it at the top, and head back to the browser. You can see that the message welcome guest is displayed, and that is because is logged in is set to false. Change it to true, and the message welcome Vishwas is displayed. Alright, the final approach is the short circuit operator approach. And this approach is just a specific case of the ternary operator approach. When you want to render either something or nothing, you make use of the short circuit operator. For example, right now we return either welcome Vishwas or welcome guest based on the value of is logged in. Now, let's say if the user is logged in, I want to display welcome Vishwas, and if the user is not logged in, I want to render just welcome on the screen. So based on is logged in, render either welcome Vishwas or nothing. To do that, within curly braces, we write is logged in ampersand Vishwas. So what happens here is the expression evaluates the left-hand side of the operator, is logged in. If it is true, it also evaluates the right-hand side, which in our case is JSX that will be rendered in the browser. However, if at all the left-hand side evaluates to false, the right-hand side will never be evaluated as it doesn't affect the final value of the whole expression. So if is logged in is set to true, you can see in the browser, welcome Vishwas is displayed. I change it to false, only welcome is displayed. As you can see, if you know JavaScript, conditional rendering is pretty straightforward. Alright, for our next topic, let's look at another common scenario that we come across when building web applications. And that is displaying a list of items. For example, a list of names, a list of products, a list of courses, etc. What we have to do is repeat some HTML for each item in the list. In React, we use the JavaScript map method to achieve that. I'm going to create a new file in the components folder called namelist.js. Within the file, I'm going to create a new function component. Export const namelist, and this is equal to an arrow function. Within the component, I'm going to create an array of names. Const names is equal to an array Bruce, Clark, and Diana. let's return a div tag. And within the div tag, we use the map method on the array. Since that is a JavaScript expression, we start with curly braces. Array.map is the syntax, so names.map. The map method takes in a function as an argument. We will be using an arrow function. The function receives an argument which I am going to call as name. You can name it anything you want to, but I recommend naming it something relevant to the array you're iterating over. Now the fat arrow symbol is next, followed by the function body, which will be the transformation. What we want to do is for every name, return an h2 tag with the name as the inner HTML. So return an h2 tag with name as the inner HTML. Once you start writing HTML, you need to reuse curly braces, so we need another pair for the name argument. And that is pretty much it. If you now save the file, include it in app component, name list, and import it at the top, head back to the browser, we should be able to see the list of names being rendered: Bruce, Clark, and Diana. Now, although this works fine, if we take a look at the DevTools console, we see a warning. Each child in a list should have a unique key prop. To fix this, on the item returned from map method, which is the h2 element, we add a key prop and assign a unique value. Since each of the names are unique in the array, we can assign the same to the key prop. If we take a look at the browser, refresh, you can see the warning has disappeared. Now, the key prop doesn't represent anything in the user interface. However, it is internally used by React to construct the list of elements in the DOM in a more efficient way. The key prop also helps prevent bugs when you're dealing with lists that involve sorting or filtering. But from a beginner's point of view, you just have to remember to specify the key prop and assign a unique value to it. If you're iterating over an array of objects, you typically tend to have an ID property that is unique and can be used as the key prop value. But this is pretty much how you render a list of items in React, using the map method. If you're unsure as to what the map method is, please do Google array.map in JavaScript and get a basic understanding of how it works. Once you understand that, you can come back to the code we have written in our component. Alright, next, we're going to learn the basics of styling and CSS when it comes to React. There are a couple of options to style React components. The first one is regular CSS style sheets. The second one is inline styling. Third, we have CSS modules. Fourth, we can use CSS in JS libraries, which work really well with React. In this crash course, we're going to cover the first three approaches. Learning a CSS in JS library is a separate series in itself, and I'll point you in the right direction towards the end of this video. Alright, let's start with the first approach, using regular CSS style sheets. Back in VS Code, within the components folder, I'm going to create a new file called stylesheet.js. Within the file, I'm going to create a function component. Export const stylesheet, and this is equal to an arrow function. In the JSX, I'm going to return an h1 tag that says Style Sheets. I will also include the file in app component. And make sure to import it from /components/stylesheet. Now to specify the CSS for this component, I'm going to create a new file called mystyles.css. I'm going to add it within the components folder. Within the file, I'm going to create a class, primary, where color is set to orange. Now, to be able to use this class in our component, we have to import it. So at the top, import /mystyles.css. Now on the h1 tag, we can specify the class using the class name attribute. Class name is equal to primary. If we save the file and take a look at the browser, the text should appear in orange. So this is the regular CSS style sheets approach to styling a React component. Next, we have inline styling. I'm going to create a new file called inline.js and create a new function component. Within the return statement, I will add a new heading that says inline. Now let's style this heading. In React, inline styles are not specified as a string. Instead, they are specified with an object whose key is the camel-cased version of the style name. For example, I can create a new object called heading and add a property font size 72 pixels, color blue. The key is the CSS property name, but as you can notice, it has to be camel-cased. The value is specified as a string. If you want to specify additional CSS properties, add a comma and then list the next property. Now to apply this style, we make use of the style attribute. To the style attribute, we assign heading. If we include this component in app component, making sure we import the component at the top and head back to the browser, you should see the text in line with the styling applied. So create an object and apply it to the style attribute. Inline styling, as you can see, is pretty straightforward. Finally, let's talk about the third approach, which is CSS modules. For CSS modules, there is a file naming convention with Create React App. The file name must be suffixed with .module.css. For example, let me create two style sheets in the source folder. If app styles.css is a regular style sheet, app styles.module.css is a CSS module style sheet. Let's make sure the spelling is correct. In the regular style sheet, I'm going to add a class, error, with color set to red. In the module style sheet, I'm going to add a class, success, color set to green. In the app component, I'm going to import both the files. import /appstyles.css and import styles from /appstyles.module.css. You can see there is a difference in how we import a module style sheet. Now, to use the error class from the regular style sheet, I can add an h1 tag that says error with the class name attribute set to error. To use the class from the module style sheet, we still use the class name attribute, but this is going to be equal to styles.success. So we access the class using the import statement variable name. If we now take a look at the browser, you should see both the classes being applied. One advantage of using CSS modules, however, is that the classes are locally scoped by default. For example, if I copy the error heading into the inline component, you can see that it still works. So the CSS kind of applies to every child component as well. This might lead to CSS conflicts. CSS modules, on the other hand, because you reference the class name using the styles variable, they cannot be used in the children component. If I copy the success heading and paste it in the inline component, you can see that the application does not compile. It doesn't know what styles is. You can't accidentally use a class that is defined for some other component. But this is pretty much the basics of styling React components. Alright, for our next topic, we are going to learn the basics of working with forms in React. We will see how to capture input from an input HTML element and have the data available for form submission. I'm going to begin by creating a new file in the components folder. Form.js. Within the file, create a function component. Export const form is equal to an arrow function. For the JSX, let's start with a form element. So return the form tag. Within the form tag, add a div tag to group together a label and input. The label is going to be username, and we add a corresponding input. Type is equal to text. If we include this component in app component, import the component at the top, save the file, and take a look at the browser, you should be able to see the label and the input field. Right now though, the form is regular HTML. We want to manage it with React. To do that, the first step is to create a state variable to handle the value and change in value of this input element. So in form.js, at the top, import useState from React. Within the component, let's create a state variable. Username. The setter function is setUsername. This is going to be equal to the useState function with an initial value of empty string. Now for the second step, on the input element, we assign username to the value attribute. So value is equal to username state variable. Now if you save the file and go back to the browser, try type in a username, you're going to find out that the input doesn't reflect the changes. Which brings us to the third step, handling the onChange event. On the input element, let's listen to the onChange event. And to this, we assign an arrow function. The function automatically receives the change event as an argument. We can use that event to update the username state variable. So call setUsername, passing in event.target.value. This is nothing but the input element's value. If we now head back to the browser and type in Vishwas, you can see it works. Alright, we are able to keep track of the change in username. Next, let's see how to submit this form data. In the JSX, within the form tag, I'm going to add a submit button. Type is equal to submit, and the text is also submit. If we go back to the browser, click on the submit button, you see that the page refreshes. So right now, the form has the default HTML form behavior of browsing to a new page when the submit button is clicked. A common approach, however, is to execute a JavaScript function that handles the submission of the form. And that form will also have access to the data that the user entered into the form. So on the form tag, we are going to assign a handler to the onSubmit event. Let's call it handleSubmit. Let's now define this handler. Const handleSubmit is going to be equal to an arrow function. This function automatically receives the submit event as an argument. To prevent the page refresh, we call event.preventDefault. And then in the next line, we simply alert the username. So alert, backticks, form data is $curly braces username. If we now save the file and go back to the browser, fill in the username and click on submit, you should be able to see the text form data is Vishwas. The page also does not refresh. This is pretty much the basics of working with forms in React. Now, as a quick exercise, I suggest you handle two more form controls. Create a text area element for description and a select drop-down element to capture a country. Handle the value and their onChange events and ensure you have the data for submission. Let me know in the comments section if you were able to achieve that. Alright, for the penultimate topic in this crash course, we are going to learn how React works with HTTP. We are going to understand with an example how to make a GET request and how to make a POST request. Let's start with GET requests. To fetch the data, we need to have an API endpoint. For that, I will be making use of JSON placeholder. As you can see here, it is basically a free fake API for testing and prototyping. I want to focus on fetching data in our React application and not on creating an API. The link is jsonplaceholder.typecode or typeicode.com. Now, if you scroll down to the routes section, you can see the possible HTTP requests you can make. For this video, I will be making a GET request to /posts, which will fetch an array of posts to display in the UI. Let's get started. I'm going to go back to VS Code and create a new component. PostList.js. And within the file, I'm going to create a function component. Export const PostList, and this is going to be equal to an arrow function. Now to fetch data, we need two hooks. useState, which we had previously seen, and a new hook called useEffect. So at the top, import useState, comma useEffect from React. Next, we are going to create a new state variable within the component. Const posts. The setter function is called setPosts, and this is going to be equal to useState with an initial value of empty array. Next, we are going to use the useEffect hook to make the GET request. The syntax is as follows. useEffect, invoke useEffect within the component. The hook takes in a function as argument. So let's add an arrow function. Within the function body, we make the GET request using the built-in fetch API. So fetch, and we pass in the API endpoint. This is the URL from jsonplaceholder.com. Copy and paste it. The fetch API returns a promise which we need to resolve. So .then block and convert the response to JSON and chain another then block, and with the data retrieved, update the posts state variable. So set posts passing in data. Let's also add a catch block and log the error to the console if there is any. Now the effect we have defined here runs every time the component renders. However, we want this to run only once when the component first renders. To do that, we pass in an empty array as the second argument to useEffect. The array is a list of dependencies on which this effect depends on. Since we want the API call to happen only once, it has no dependencies. The final step is to render the list of posts in the browser. So return a div tag, a UL tag, and then curly braces posts.map. We have already seen how to render a list of items, so let me go over this fairly quick. For each post, we return the li tag, and each post has a title that we can display. We should also specify a unique value for the key prop, which is going to be post.id. You can see here that each object in the array has an ID and a title. Alright, let's include this component in app.js and test it out. Post list. And if that doesn't auto import for you, make sure to import the component at the top. Post list from /components/postlist. If we now head to the browser, you should see the list of post titles being displayed. This is pretty much how you fetch data with useEffect and display the data with useState. useEffect is a hook that you can use to make side effects in your components. The side effect in this example is an API request. The first argument to use effect is a function, and the second argument is a dependency array, which is used to determine when to rerun the effect. Since we have an empty array, the effect is run only once when the component first mounts. Now on similar lines, let's see how to make a post request to send data from our React application. If we go back to JSON placeholder, under routes, we have a small note. See guide for usage examples. Here, if you scroll down, you can see we have the code necessary to make a post request. However, the data it needs, which is title, body, and user ID, are hard-coded. Let's instead capture user inputs and make the post request using that data. Back in VS Code, I'm going to create a new file called postform.js. Within the file, I'm going to create a function component. Export const postform is equal to an arrow function. Now for the JSX, we need a form with 3 input fields. So return a form tag, a div tag, type is equal to text, and placeholder is user ID. The second input, placeholder, is title, and the third input, placeholder, is body. Next, let's create state variables for the 3 fields and link them to the input elements. At the top, import useState from React, and within the component, call useState 3 times for each of the 3 inputs. The first one, const user ID, set user ID, and the initial value is an empty string. Similarly, const title, set title, and the initial value is an empty string. Finally, const body, set body, and the initial value is an empty string. On the inputs, let's assign the appropriate variable to the value attribute. Value is equal to user ID. Value is equal to title. And value is equal to body. Also, handle the onChange event. You get access to the event, and on the first input, we call setUserID passing in event.target.value. Similarly, on change, event setTitle event.target.value, and on change, event setBody event.target.value. The last thing we need is the submit handler. I'm going to add a button of type submit. And then on the form tag, we listen to the onSubmit event and assign a handler. Submit handler. Let's define this handler. Const submit handler is going to be equal to a function which receives the submit event, and within the function body, we call event.preventDefault to prevent the form submission and page refreshing. Finally, to make the post request, copy the code from JSON placeholder and paste it. However, change the hard-coded values. Title, body, and user ID. The other noticeable difference with the built-in fetch method is we now have method set to post and headers. With the response, we simply convert it into JSON and log it to the console. Now, let's include this component in app component. Import the component at the top, save the file, and head back to the browser. I fill in user ID, title, body, and click on Submit. In the console, you should now be able to see the response. If you expand the object, you pretty much get back the same object you posted, but this time with the unique ID. This object can be used for any necessary changes in the UI. For example, you can add this object to the end of the post list, which might be displayed in the browser. So there you go, making a post request in your React application. Create the input fields, tie the values to the state object, and make a post request in the submit handler. Once you get the hang of get and post requests, making put or delete requests is pretty much the same. So I will leave that for you to experiment with. Alright, for our final topic, we're going to learn about the useTransition hook, which was introduced in React 18. Unlike useState and useEffect, useTransition is a hook that is more concerned with performance rather than supporting a core functionality. The best way to understand useTransition is with an example, so let's dive into the code straight away. For this example, we need a large list of items. I'm going to create a new file called data.json and copy-paste an array of 1000 names. I have used mockaroo.com to generate this JSON data. Each object in the array contains a unique ID, first name, and last name. Now that we have our list, let's render it in the app component. At the top, begin by importing the names JSON. So import names from /components/data.json. Next, in the JSX, we render the list of names using the map method. Very similar to list rendering that we have learned earlier. So curly braces, names.map. Map accepts a function as argument. This function receives each object in the array as an argument. Let's call it item. For each item, we render a paragraph that displays the first name and last name. So item.firstname followed by item.lastname. Make sure to also include the key prop with a unique value when rendering a list of elements. Key is going to be equal to item.id. If we save the file and take a look at the browser, we should be able to see the list of 1000 names being displayed. Now, what we want to do is allow the user to enter a filter text and filter the list of names based on that text. Let's begin by adding the input field. At the top, import useState from React. Within the component, create a state variable to manage the text field value. So const query, set query, and this is going to be equal to useState with an initial value of empty string. In the JSX, add an input field. Type is equal to text, value is equal to query, onChange is equal to change handler. Let's define the handler. Const change handler is equal to an arrow function. This receives an event, and within the function body, we call setQuery, passing in event.target.value. Now let's filter the names with this query text. Const filtered names is equal to names.filter, and for each item, we return either item.firstName includes the query text, or item.lastName includes the query text. Finally, instead of mapping over names, map over filtered names. If we now save the file and head to the browser, we have our input and the list of names. In the input field, type bin, and we see the filtered list of names. Everything works well, but that is dependent on the machine you're running the application on. I have decent specifications on my machine, but not everyone might have that. So let's open the DevTools, head over to the Performance tab, and throttle CPU. 6x slowdown. We are basically asking our React app to be run on a computer that is 6 times slower. I want you to now observe what happens when I select the full text and hit backspace. 3, 2, 1, and backspace. You can see there was a lag for almost a second before the UI updated. And this is because the filtered list of names had to be recalculated. If I type in bin again, it feels slow as well. It might not be visible to you, but I can also sense the lag when typing. What I want you to observe is that when I clear the text, it is not cleared out right away. Instead, it waits for the filtered list to be recalculated, and both the input field and the list of names then update at the same time. Backspace. And you can see both happen at the same time. This is because, by default, all updates in React are considered urgent, which, as you might see, can create a problem when quick updates like updating the input field text is slowed down by heavy updates like recalculating the filtered list. To solve this problem, what we need is a way to tell React some updates are not urgent. That would help React process the urgent updates first and then the not so urgent updates. This is where the useTransition hook comes into picture. The useTransition hook allows us to mark some updates as interruptible and non-urgent. Or in other words, we can mark them as transitions. React will process urgent updates first and then transitions to improve the perceived performance. Let's see how it works. First, import useTransition from React. Next, invoke it within the component. The hook returns two values. Is pending, which is a Boolean value indicating whether the transition is in progress, and a start transition function, which is used to mark heavy updates as transitions. Next, we are going to create another state variable to manage the input text value separately. So const input value, comma set input value is going to be equal to useState with an empty string as the initial value. But now we update the value prop to input value, and in the change handler, call set input value. Set query though, we will still update with the input value, but as a transition. So within change handler, invoke start transition function, which accepts a callback. So pass in another function, and here we call set query, passing in the same input value. So start transition accepts a function where we make the state change that causes a heavy update. Query is used in the filter function, which is the heavier operation. In the JSX, let's use the isPending flag to render some text and indicate that the transition is still pending. So below the input, curly braces, isPending, and a paragraph tag that says updating list. If we now head back to the browser, type bin, we see the filtered list. But when I clear out the text, I want you to observe that the input field text updates first and then the filtered list updates after a small delay. We will also see the updating list text below the input since the transition would be in progress. 3, 2, 1, backspace. We can see input is now cleared. We see the text updating list, and finally the list updates. So we are able to separate the urgent updates from the non-urgent updates. This gives you a small improvement in the performance, or at least the perceived performance. That is how the useTransition hook functions. Now, as a beginner, this is the only new feature from React 18 that you need to be concerned about. Other features include automatic batching, which is out of the box and you don't have to write any additional code, and a few other features related to suspense and server-side rendering, which are again advanced topics. With that, we come to the end of this crash course on the fundamentals of React. From here, I would like to suggest the next steps that you can take to continue down the React path. First, go through my video on the React roadmap for 2022. This will give you a big picture of React and its ecosystem. After that, start with my React playlist. It covers pretty much every concept you need to know about React. Class components, the advanced concepts, advanced hooks, how React components re-render, the optimization techniques, and how to use React with TypeScript. You can then start on some libraries that help build large-scale React apps. React Query for all API requests, Material UI, Chakra UI, or Mantine to work with readily available UI components, Formic or React Hook Form for complex form management, and finally, Next.js, which is a React framework for production. Over the past few years, I've tried my best to make this channel a one-stop shop for everything related to React. So you will find a lot more playlists on libraries that I haven't mentioned as well. For example, React Router. Browse through the channel and learn something that is of interest to you. I guarantee you'll not regret it. If you have enjoyed the video, please do leave a like and subscribe to the channel for more content on web development.